Good morning. Today we will study another one type of the discrete probability distribution that is called as Poisson distribution, or else you can pronounce it as Poisson distribution. The distributive function is defined as m to the power of x into e to the power of minus m by x factorial, where m is nothing but fixed finite constant. X is nothing but a Poisson variate, or the random variate. X is nothing but random variate. Since we are applying it for Poisson distribution, it is called as Poisson variate. Now, next we will discuss, is it this function satisfies the probability function definition or not? What is the probability function definition? Where any probability function should satisfy the condition p of x should be greater than or equal to 0 and summation of p of x should be equal to 1. So let us form a distribution of the probabilities for different random variables 0, 1, 2, 3, etc. P of x, here nothing but a Poisson distribution. What is the formula? M to the power of x e to the power of minus m by x factorial. Keep on substituting x values. When x is 0, m to the power of 0 is 1, 0 factorial is 1. So what is left out? E to the power of minus m. When x is 1, m to the m into e to the power of minus m by 1 factorial. When x is 2, m square e to the power of minus m by x 2 factorial. That itself is here written here. Similarly, for x equal to 3, m cube e to the power of minus m by 3 factorial, and so on. Observe that here none of the terms are negative. They are all positive. So the first condition of the probability function satisfied. P of x is greater than 0. Second condition is add it all this distributive function. So what will be the distributive function? Added these terms. Here that step itself is shown. E to the power of minus m plus m into e to the power of minus by 1 factorial, m square into e to the power of minus m by 2 factorial, m cube by e to the power of minus m by 3 factorial. Observe that e to the power of minus m is taken common from all the term. What is left out? 1 plus m by 1 factorial plus m square by 2 factorial plus m cube by 3 factorial plus etc. This is nothing but a series expansion. We have studied it in first year, a Maclaurin series expansion. So here when you see that this is a Maclaurin series expansion of exponential function of variable m. So this series is written as e to the power of m. So when bases are same, add the power. So e to the power of 0, we know the value is 1. Hence this p of x satisfies both the condition of probability function. P of x is nothing but a probability function. In particular, it is called as Poisson probability function. Now we will study mean and standard deviation of this Poisson distribution. How we have studied it, mean and standard deviation of binomial distribution. In the same way, we need to study mean and standard deviation of Poisson distribution. The derivation of mean and standard deviation of Poisson distribution is important for the examination point of view. They will ask you any one, either binomial, Poisson, or next distributive functions what we are going to study. So among any one they will ask. We know mean formula for discrete probability distribution, summation x into p of x. Substitute p of x formula, m to the power of x e to the power of minus m by x factorial. This x factorial, to cancel this x, can be written as x into x minus 1 factorial. The same way how we simplified in binomial distribution, in the same way here also in Poisson distribution, while finding mean we are simplifying it. So cancel this x and x. What is left out in the next step in the denominator? Only x minus 1 factorial, where x varies from now where to where? 1 to. Now since here it is x minus 1, numerator also we make m power with x minus 1. So which is the extra we have taken? M to the power of minus 1 is extra. To compensate with this step, we take m to the power of plus 1, and which does not contain x. Hence we have taken outside the summation. And e to the power of minus m also does not contain x. Hence take it outside the summation. Now expand this term, summation term, by substituting x is equal to 1, x is equal to 2, x is equal to 3. When you do the substitution, observe that m to the power of 1 minus 1 is 0. M to the power of 0 is 1. 1 minus 1 is 0 factorial. It is also 1. So 1 by 1 is written as 1. Next x equal to 2. 2 minus 1 is 1. So m. 2 minus 1 is 1 factorial. Then x is equal to 3. 3 minus 1 is 2. So m square divided by 2 factorial plus etc. So again this is nothing but a Maclaurin series expansion of exponential function with variable m. So when bases are there, add the power. So you will get e to the power of 0, and we know e to the power of 0 value is nothing but 1. So m into 1 is m. So mean of the Poisson distribution is nothing but m, which is the finite variable. Next, variance. Next we will study variance. It is defined as summation x square p of x minus mu square. Now let us find out first only the summation of x square p of x. In binomial distribution also, for the easy simplification, we have converted x square in the linear form. It means power of 1. How to split x square? How it can be written in the form of linear? X into x minus 1 plus x, because x into x becomes x square, which is the which we have in the previous step. So minus x is an extra. To compensate that, we have taken plus x into p of x. P of x is nothing but here probability Poisson distribution, p m to the power of x into e to the power of minus m by x factorial. Now multiply this Poisson distribution to each bracket and write x factorial to cancel x into x minus 1 as x into x minus 1 into x minus 2 factorial plus summation x into this. So to cancel the x term, write x factorial as x into x minus 1 factorial, where x and x get cancelled. Now what is left out answer I have written here. Now here you do the observation. M to the power of x e to the power of minus m by x minus 1 factorial summation is nothing but the step what we got here in the mean also. So this step is nothing but what? It is equal to mean. What is the mean of the Poisson distribution? We got it as m. So in the next step we write this term as m. And since here x is in the form of x minus 2, in the next step we write power of m also in the form of x minus 2. How we are written it as m to the power of x as x minus 1, because in the denominator it is in the form of x minus 1. In the same way here denominator term of x is in the form of x minus 2. Hence power of m, write it down as x minus 2. So m to the power of minus 2 is the extra term. To compensate that, we take m square, m to the power of plus 2. That is shown in the next step. Observe that m square e to the power of minus m does not contain any x variable, so taken outside the summation. So summation m to the power of x minus 2 by x minus 2 factorial plus second term is nothing but mean of the Poisson distribution, which is taken as m. Expand this summation, you are going to get the series expansion of exponential e to the power of m. So when e to the power of minus m, e to the power of m simplified, you will get it as e to the power of 0, which is equal to 1. So m square plus m is the answer of summation x square p of x. So substitute in the formula of a variance, summation x square p of x is m square plus m minus, what is the formula of variance? Summation x square p of x minus mu square. Mu is nothing but mean square. So mean is nothing, substituted as m. So m square get cancelled. What is left out? M. So variance of a Poisson distribution is nothing but m. We know standard deviation is nothing but the square root of the variance. So standard deviation of the Poisson distribution is square root of m. In the exam, they will ask you to obtain the mean and standard deviation of Poisson distribution, or they may ask you prove that mean and variance of Poisson distribution are equal. Observe that mean and variance both value are m. Hence we say that mean and variance are equal in the Poisson distribution. Thank you.